So this video is going to recap everything you need to know about analysis and testing for gases for the IGCSE chemistry course. The first thing that we're going to look at is flame tests, and you need to be able to recall the equipment that you use for a flame test. The first thing that you need to know is that you have the use of a nichrome wire. So it's a piece of nickel chromium alloy that has a little hoop here at the end. This hoop here at the end you can put into your metal ionic substance here. So what you would have is you'd have a sample of an ionic compound, okay, e.g. lithium chloride. So you'd put your nichrome wire and you would dip it in the chloride like so. Once you've done that, you would then put your lithium chloride in the blue Bunsen burner flame. So blue Bunsen burner flame. And then if it's lithium, what you would see is that you'd start seeing a red flame being given off there. Okay. Once you're done with that, what happens is that you've now got a dirty nichrome wire using a watch glass. So I know in class we cleaned it using a test tube, but in the textbook and for the exam, they expect you to say watch glass. So you have a watch glass here, and that is going to be filled with hydrochloric acid. Okay, to clean. Now you need to know 5 different colours for the Edexcel IGCSE A level. The first one you need to know is lithium. So lithium plus gives a red colour. Sodium gives a yellow colour. Copper 2 plus gives a blue-green. Actually, let me correct that. Let me at least write green in the green pen and blue in the blue pen. So this one's at blue-green, so I'm just going to accent this green with some blue. The others that you need to know is calcium. Now, calcium, as we say, is an orange, or in older textbooks, you'll see it as a brick red. And the final one is potassium, and that gives you a lilac flame. Other ones that are beyond the spec is that barium gives you a pale green, and strontium gives you another red colour. Now, there are other ways that you can test for cations as well, and that's by using sodium hydroxide. You can do this for the following. You can do this for solutions of iron 2 complexes, iron 3 complexes, and copper complexes. So on the addition of sodium hydroxide to an iron 2 solution, e.g. iron 2 sulfate, what you would see is a green precipitate. And we'll come back to this one later because you'll see a change over time. For iron, what you see is a brown precipitate. So I'm going to see if I can get a shade of brown. Yeah. So you get a brown precipitate. And then for copper, like the flame test, you get a blue precipitate. The interesting thing about iron 2 is that initially you get a green precipitate. So precipitate is a solid that comes out of a reaction of two solutions or two liquids. But over time, so let's say about 20 minutes, what would you see? You would see actually still mostly be green, but at the top you'll find a layer of brown precipitate. And this brown precipitate is formed from oxidation of FeOH2 to FeOH3, okay, from O2 in the air. And again, all these precipitates are metal hydroxides. So the green precipitate would be FeOH2, brown precipitate would be FeOH3, the blue precipitate would be CuOH2. There's also a final cation that you need to know the test for, and this is the odd one out because this is the only cation, the positive ion, which is not going to be a metal, and that is the test, for the ammonium ion, which is NH4+. What you do for that is the first thing is you add NaOH, and then you warm the solution, and then the gas evolved will turn red. Oh, sorry, I need to correct that. Will turn damp red litmus paper blue. So what would you see? So if I draw the appropriate diagram quickly, so what you would see here is that when you hold over your red litmus paper, the fumes, once they touch the damp surface, will turn that damp red litmus paper into a blue colour. And that's the test for ammonium ions. We then get to the third part of this, which is the tests for anions. There are three types that you need to know. The first type is halide ions. What you do for this, the procedure is as follows. 1, add dilute nitric acid. To remove any carbonate ions, because silver carbonate is a white solid, so you don't want to have a false positive. The same is true why you don't use hydrochloric acid, because hydrochloric acid has chloride ions, and if you have chloride ions, you're going to get a false positive of a white precipitate as well. Then what you do is you add in silver nitrate solution. which is AgNO3. And what you see is the following. You see a precipitate. So if I do the ionic equation, so if we have chloride ions present, silver reacts with the chloride ions, form silver chloride, which is a solid, and that, if I white precipitate, I'm going to use PPT as the shorthand way of writing precipitate. If we then react it in the presence of bromide ions, you get silver bromide precipitate, which is a solid, and that gives you a sort of odd beige colour. So I'm just going to have a go at trying to find a beige colour. So we sort of have a cream or a beige precipitate. Then finally, it's the iodide. So that forms silver iodide, and that one is a yellow precipitate. If you want to do additional research, you can further distinguish these by using dilute and concentrated ammonia. So if you want to have a look online, you can use dilute and concentrated ammonia to further distinguish these. But now I'm going to stop there for that video. The next thing I'm going to do is have a look at carbonate ions. The test for carbonate ions is as follows. What you do is you add any acid. So that could be hydrochloric acids, that could be nitric acid, that could be sulfuric acid, could even be phosphoric acid as well. So any acid, you could have a carboxylic acid like ethanoic acid as well, it doesn't matter. It should involve a gas, which when tested with lime water, should give you a cloudy precipitate. So a cloudy precipitate. Sulfate ions have a different test. The first thing you do is that you add specifically hydrochloric acid, and this removes any sulfite ions. So they're different to sulfate, they're SO3 2-. Then what you do is you add barium chloride solution to that, and what you should see is a white precipitate. So the result for sulfate ions is that you add HCl first, and then you add barium chloride. That then gives you a white precipitate. The penultimate tests that you need to know are for the various gases. So you need to know, for example, how to test for hydrogen gas. Hydrogen gas, you test with a lit splint, and you should get a squeaky pop. Carbon dioxide, we've seen this before. Bubble through lime water. What should happen is that it will go cloudy. Oxygen is that it relights a glowing splint. Okay, so it's a glowing splint. Ammonia is just one step removed from the ammonium test, because ammonia is a gas, and the gas that is evolved when you react ammonium with sodium hydroxide is ammonia, so it turns it turns damp red litmus paper blue. Chlorine gas you should be able to observe as a green gas, which turns damp blue litmus paper red, so it's the reverse of ammonia, and then bleaches it white. So there are 1, 2, 3, 4 things to remember. 1, green gas. 2, damp litmus paper. 3, that turns red. 4, it then bleaches it white. The final thing is what we're doing is looking at water. Water, in terms of testing for water, there are 2 types of ways of doing it. There's a chemical way of testing for it. So a chemical test would be using anhydrous copper sulfate. Remember, that's actually copper 2 sulfate. And that goes from a white powder to a blue solution. That's actually one way of doing it. There's a second way of doing it, which is using cobalt chloride paper. And that goes, in the presence of water, from blue to pink. So it goes from blue to pink. And the final way is looking at it from physical tests. So pure water will boil at exactly 100 degrees Celsius, or will freeze at exactly 0 degrees. And there we have it. That is everything that you need to know for Edexcel IGCSE chemistry in terms of chemical analyses and tests.